Okay, so how about a PhD in free energy? How does that sound? A doctor of philosophy in free energy. Okay, you ready for this? Me too. So the goal in education is always to study thoroughly, understand thoroughly, and then in the end, to be able to explain what we've learned. This is a very important part of education. If we leave this part out, then our work is not done, right? It's important to be able to teach and explain the complexity of what we've learned in extremely simple terminology and simple examples. Right? Einstein told us this, and many philosophers and the greatest thinkers in history have shared this with us. I'm going to share with you the simplest free energy system that I'm aware of. So right now I have many different electric micromobility, electric bicycles, electric scooters of different kinds and types. And what I'm going to do is, so let's say the bicycle has a battery. We'll say this is the battery, right? Battery. And here's the bicycle. Okay, this is not a perfect bicycle, but it's just, it's an electric bike. Okay, and there's going to be probably motors inside the wheels, or it could have a motor up here somewhere with a chain. Some electric bikes have that as well. So we'll say this one has motors in the wheels, but it actually, wherever the motor is fine. But my electric bike has the motor. Where's the motor? Oh yeah, it's a hub motor, so it's here inside the wheel. Okay, so now what I'm thinking about doing is, this battery is, well, let's say it's, we'll say this one is 60 volts, right? This battery is 60 volts. It's called nominal. But the charger says 66 volts, right? Fully charged. Okay, so the nominal voltage and the fully charged voltage I think they're always different. So this one's 66 volts, and that's the voltage I never want to go past, right? I mean, the charger may say 67.4 volts or something like that. But I don't want to go past this voltage when I'm charging it with my system that I'm going to use, right? With the system I'm going to add to the scooter, to the electric bike. And the way that's going to work is, let's say that the battery, I'm going to move the battery over here now, right? This is the battery. I'll say this is the 66 volt battery. Fully charged, right? I'll say this is plus and minus, and I'll say this is the plus and minus poles. And if I understand correctly, let me think about this. I think a fully charged battery, I always get this mixed up. I'm doing my best to learn this though. I think a fully charged battery has all the electrons from the battery on the negative side. And then I think when it's equalizing, right? Or I don't know if they all go to the plus, or if it just goes, half of them go to the plus. I'm not sure about that. Maybe all of them go over there, or just half. Because what's equilibrium, right? Does the battery go to equilibrium? Is that when it's drained all the way? Do all the electrons go over there? I don't know. But I think fully charged is when they're over here, and I think depleted is when all the electrons go to the plus, right? They've already moved over there. So they're going from one side of the battery to the other. But the energy's not lost, right? It didn't go anywhere. It just moved from one side of the battery to the other side. That's my understanding. So please confirm that for yourself. Sometimes these simple ideas are really hard to figure out. And sometimes I feel like I'm getting two different answers, or even many more than two different answers, when I try to learn something like this. But recently I was just reading that the electrons are on the negative side when it's a fully charged battery, and they want to go over to the positive side, and that's when the battery drains, when they move over there. So you can study Rick Friedrich, the diagrams that he shares with everyone, which is really other engineers' work. Rick Friedrich kind of reminds me a little bit of Tom Bearden, in that Tom Bearden was a researcher and he collected works of many, many people. And Rick Friedrich is a researcher that collects the works of all the great thinkers throughout history, electrical and mechanical engineers. And Rick's a master of collecting that information. And to me, that would mean that Rick could put together a lot of books that could help us understand. He does do that. He puts material together, which is available. You can purchase copies of the material. But I feel like it could be like in one big book, or just like, I would like to learn everything. I just want to buy everything that Rick has ever written. I would like to buy that because I like learning. I want to learn everything I can learn, right? From this planet and all the other planets. That's why we're studying this book, right? This book has a perpetual motion machine in it. That book right there has a perpetual motion machine in it. You want to see it? I'll show it to you real quick. This video is supposed to be about what I'm doing to the bicycle, but I know you want to see the perpetual motion machine from a different planet, right? There it is. These are electric motors and generators. Think of John Bedini, right? John Bedini would combine a motor and a generator in one system. So each of these spin, and these are, I think of these as like gyros right here. These are just gyros. Now I think they're showing us here is what's inside that motor generator. Inside there is this, see? I think that's what that is. See how it says north there? And I don't know what Z stands for. We'd have to read all this to find out what that is. But yeah, there it is again. That's a perpetual motion machine. Now, just to be clear, perpetual motion is not the bullying, perverse, and what is it? Yeah, the perverse definition, which is it never is allowed to get maintenance, and it's not allowed to be powered by the perpetual wheel works of nature. That's the perverse use of the word. The actual user use of the word, meaning the inventor's use of the word, is that the machine does need maintenance, right? It's going to need bearings maintained. It might need oil once in a while. And it is powered by the open super system of the universe, right? It's powered by cosmic energy. So people make fun of perpetual motion machines, saying, oh, well, they never need the bearings changed, they never need maintenance, and they're not powered by the universe. They just make their own energy. But that's not how they work at all. Perpetual motion machines need maintenance, and just like any other motor or generator, they need maintenance, but these are powered by cosmic energy rather than powered by a fuel source or by putting electricity into it, by plugging it in, right? These stands right here just hold this up. That's all these do. The energy is coming from the whole universe, cosmic energy, right? And all energy is interconnected. So that's how that works. Okay, going back to the thought you might be interested in that. It interests me. Going back to the PhD in free energy is, so we have the battery here, and what I'm planning to do is, see, I could get another battery at this exact voltage. I don't have a battery at that voltage right now that's extra. I don't have an extra battery that's exactly 66.6 volts fully charged. I have some 58 volt batteries. I have lots of 42 volt batteries. So I'm thinking of taking like any combination of batteries that's a higher voltage than this, okay? So I'm thinking of using like two 42 volt batteries possibly. And I'm talking about 42 volts. These are called 36 nominal, right? So I'll say 36 volts nominal equals 42 volts fully charged. Okay, if I take two of these 42 volt batteries, then we're going to have 84 volts. 84 volts being higher than 66 volts allows me to do this experiment I'm going to do right now. Okay, and please confirm this for yourself by getting the diagrams, download and print all the diagrams for the loving giving path. There's many different diagrams, some very simple ones, which are the ones I understand, and some much more complex ones, which I'm sure most people understand, but I'm still working on it. I always find that I'm the last person to understand something very simple. That's okay though. I'm fine with that. As long as I don't give up, I'm happy. And I actually don't know how to give up, so that's a good thing. It's not in my vocabulary. Okay, so we have 84 volts. And I'm looking at the phone screen when I draw, so it's going to be a little bit, there might be a delay when I reach to see where the page is, because my depth perception is a little bit inaccurate looking at the screen of the phone to draw here. So now we have our 84 volt battery, and we're going to say this is, on this battery, we'll say again that this is the plus, and this is the minus over here, okay? Now I'm going to circle these just so I can help myself realize that that's separate. That's just information. So my understanding of what I can do with these two batteries, and ideally I'm gonna if I can, I want to go around the BMS on this. What I mean is, I'm going to be running a motor between the positive wires, like a brushed motor, or if I'm not sure I'm using the correct words, but I'm going to call it a pulse motor. So I don't know if there's a 2-wire pulse motor, and I also don't know how to modify that motor so that it pulses in both directions. So it sends a pulse to this battery and to this battery. I think there's a diode that can be moved or taken out, and there's a few things that can be moved around in a circuit of a pulse motor, if I'm saying this correctly. If you look at the diagrams of the loving giving path that Rick Friedrich has put together, and that's just a collection of previous electrical engineers' lifetimes of work. And please do study all that if this interests you. If this interests you at all, that's the place to go. That's the source. Go to the source, right? Well, the source is the engineers that Rick presents. They're the source, and Rick has just assembled that for people to make it easy. But you can also find the people directly by looking for their names directly as well. But at the moment, I'm just going to say the loving giving path will have all this information. So, but even if I don't modify the motor I'm going to put in here, and I just use a regular brushed motor, so let's say I connect the negatives together. Now let me think about how I'm going to do this. Because one way I can do it is just connect this negative to this negative, and then put the positive wire into a motor, into a brushed motor that has 2 wires, right? And have this plus go into the plus side of the brushed motor, and the negative side goes to the positive of this, right? And that'll make that motor turn. And the motor kind of acts like, a lot of people look at that and say, oh, the motor's acting as a resistor, right? It's slowing down this battery, sending its power to this battery. But what's interesting to notice, and the way it's said, the way I've read this to be said, is that this battery is charging this battery at the rate of powering this motor. So if this motor is like a really big motor and it's also doing work, so if it's taking amps to make this motor turn, like let's say this motor is helping make the bicycle move, right? Which I'm not planning on doing. I'm not planning on putting any load on the motor. At the moment, I'm not planning on it. I might put a fan on it. If it could have an internal fan, that would be ideal, so it can keep itself cool. I would also like it to spin at a very high RPM to have that ability, like maybe 100,000 RPM. I would like that because I think it sounds neat when a motor's winding up really loud. But if it has no load on it, that might be hard on the bearings. So I'd have to make sure it can handle that. But what I'm thinking of doing is having this go to a pulse width modulator, or just a motor controller, right? So this will go to, I'll say a motor controller. a motor controller, and we'll call that a PWM. I think Amazon sells those. I think you can get those anywhere on the internet. But it would need to be, okay, we'll see that's plus and minus. It would need to be the voltage range of what we're dealing with here. So input would have to be ideally maybe up to 100 volts, or at least like 90 volts maybe, but at least 84 volts, right? But higher is a little bit better. If it's like a little bit higher, like 10 to 20% higher than this, that's ideal. And then down to, let's see, output would be, output would need to be able to be at least 66 volts, right? So output range would be good if it could have a range, maybe from, I think I usually buy them that have a range from like maybe 10 volts up to 90 volts. But you confirm that for yourself by looking them up. There's many choices. So now the output, I'll say there's a plus and a minus, right? So this minus will go to this battery minus, and then the plus, I'll go over this wire. That means I'm going over the wire without touching it. We'll go to, oh, I'm not going to forget the motor, right? So I'm forgetting the motor. So let's put the motor here. So here I'll put a motor. But this is really just a load, right? So this could even be lights. That might be a good way to do it. That way the bicycle can be lit up and I'm using the energy for something. I'm just realizing that right now. That might be a better way to do it. That way I'm running lights. Now, let me tell you something that's interesting about this. Now, why are we calling this a free energy system? Why are we calling this why am I calling this a PhD in free energy, right? And please do confirm this for yourself, but this is my understanding. What the interesting thing about this is, this plus wire right here, I think this becomes what's called a negative resistor wire. I think that's the right way to say it. And what happens here is anything that's put in this wire, if I understand correctly, please confirm this for yourself. I'm still learning. But anything I put in this wire is not consumed by the loads in this wire. And the reason for that is that we're sharing the energy from this battery with another battery. Okay, now I know this works if we don't have the pulse width modulator there. Usually that's what we say. If I just connect this like this negative wire directly to that battery and this plus wire through the motor into that battery. But I don't know if having this here changes anything, and I've done a lot of experiments where I put a pulse width modulator in there and the energy did seem to be not being lost. Like the efficiency seemed the same. Because what happens is we can move this energy over here, and then if I have a couple batteries in in series here and a couple batteries in parallel here, then I can put these in series and these in parallel, and then I can send the energy back, and I can go back and forth, right? And I can use this to control the speed of this motor, right? Or I guess if it was lights, I can control how much power the lights are getting. And I haven't done it with lights on this kind of circuit, like on this scale. I've done it with like small batteries and things, but I would have to see how that could work, and that could be experimented with. Some people do this at their homes, and they have large battery banks over here. They have 2 battery banks, and they use it to heat their home. They'll run a heater, right? Some kind of heater between the 2 sets of batteries. And because no energy is lost to power the heater, right, it all goes into the other set of batteries. That's my understanding. And that energy can just keep being sent back and forth. Now, there's some losses, so eventually the voltage will go down. But other things that could be done are, check this out. Look how interesting this is. This is a motor, right? And we're going to say this is plus and this is minus. So if this wire goes into the plus and the minus goes to this plus, because we're splitting the positive, right? This is called splitting the positive. then what happens is I could have generators over here. This motor, this could be a big motor, and this motor can be spinning generators, like an alternator or several alternators, and the output of that can probably be stepped up if needed, or just directly, or the alternators can be wired in series to get the voltage higher, and then those can go to, what would those go to? Some people have that go back and charge this battery, but because this battery's has a load on it, right? And it's harder to charge a battery that's under load. It can be done, it's just harder to do it. It's less efficient to do it. And so I wonder, could we use that energy being generated to power this battery, even though this battery is already being charged, because the only reason I'm thinking that is because this one's not being drained, it's being charged. So it might be more efficient to charge this one, and it would just charge faster, right? And we could have more batteries over here in parallel. So I could have another 66 volt battery in parallel, and I'm charging those with the generators that this is turning, right? So so that might look something like this. To say there's let's say I'm using 4 alternators, right? So 1, 2, 3, 4, and then we'll say these have pulleys on them. And this has a pulley, or just has this pulley on it. And these come out here. And then they'll have a belt, maybe a belt. Now the belt would, in this way like this, if I just run one belt here, it might just slip. I mean, maybe a chain could be used. But I'm just going to put something here for the moment just to show that these are all connected, right? So these are all connected. That's the idea. And then how that's done exactly could be determined by whoever's doing this in the most efficient way that you find to do this. And then these can be all wired in parallel, or 2 in parallel, and then the 2 sets in series to bump the voltage up. Or they all could be in parallel, or they all could be in series, and just see what's most efficient. I've been told by people that have experimented with alternators, that have experimented with using alternators, I think they used, let me think about this, 4 alternators and 6 batteries, or not 6, is it 6 batteries? I don't remember if it was 6 batteries or not, but it was 4 alternators, and I think they were trying to get the voltage as high as they could to keep those batteries charged in an electric vehicle range extender project they were doing. And I've looked up on the internet and just found student engineers working with teachers on projects like that, where they're using alternators on electric cars and electric motorcycles to extend the range of the electric vehicles. Now, some people say, well, that violates this and that and all those things. But remember, we're not violating theories and principles, right? Laws are theories and principles. So first we call it what it is. It's a theory and a principle. And if this configuration of an electric circuit creates an opportunity for a different kind of theory and a different principle, then that's to be observed, especially if it's repeatable. And when students are doing this, student engineers are achieving range extension with alternators. And I'm not even talking about a circuit like this. I'm just talking about an electric motor, a very big, powerful electric motor, spinning alternators, but also powering an electric car or electric motorcycle, and then keeping the batteries charged, right? But there's always this configuration too, something like this, which this looks like more work because it's like, oh, now we have to change the parallel into series, and we have to change, we have to keep going back and forth. These in series, these in parallel, and then these in series and these in parallel, and rewiring it each time, right? But what I'm planning to do is, just as a range extender, right? So since I have these 2 42-volt batteries, but I don't have another 66-volt battery, I'm thinking, well, I can take 2 42-volt batteries, I'll have 84 volts. I can run those 2 batteries in series that are fully charged, into this pulse width modulator motor controller, which is made to control a motor, run the negative wire from the pulse width modulator directly to this battery, my electric bike battery, right? And then the positive, I'm splitting the positive by going through this brushed motor, or I think any kind of motor that will take 2 wires to spin, right? That takes DC, direct current from batteries, right? And can accept 2 wires. That way we can split the positive, right? Because if it has more than 2 wires, then I'm not sure how that would be done. But there are brushless 2-wire motors. I've seen like big fans for computers that are brushless inside, and somehow they do work, right? But that kind of system is not going to send a pulse back into this battery, because there's ways to do this as well, where the pulse goes both to this battery and some of that pulse can go back to this battery. Not when we have this here, but I mean if we're going directly between 2 sets of batteries, the pulse can pulse both ways, and actually it can be balanced when you get really good at this. This is what the advanced circuits show, that there can be a way to help slow down how fast this battery discharges. But the interesting thing about this, and the reason I'm calling it a PhD, a postgraduate degree in free energy, is because it's achieved that simplicity of free energy, which is anything that's put between this positive and this positive is not lost, whether it be lights or electric motor and whatever work it does. So when you put a load on this like this, what happens is the current increases, right? It's going to take more current, but what happens is that current goes into this battery. Whatever current this takes to run will just be charging that battery at that current. So that current's not lost to the environment, it goes here. So instead of going like this to the battery, remember we talked earlier about how a depleted battery, a fully charged battery, has all the electrons on the negative side, and then as the battery depletes, those electrons go over to this side. Well, in this configuration, right, in this configuration, it looks like what's happening is the electrons are being shared with another battery, right? I mean, sorry, yeah, they're being shared with another battery, but they're also being shared with this. That's why it's called the loving giving path, because anything in this line is not lost. It's like a water wheel, right? It's like a water wheel, water going down a river, and it's spinning this motor as it goes down the river further, which is here, right? This is like the ocean, where it gets rivers connecting to the ocean, right? Kind of like that. So it's an interesting idea, and I added some things here, but I'm just showing the basic idea. I'm trying to show the basic idea, and I'm sharing what I'm planning to do, which is to spin a motor. I may not put generators on it right away, but I'll spin this motor, and what's the use of that? Well, the use of it is it's letting me use the energy in these batteries to extend the range of this, and when I'm not even riding, when I'm just sitting there waiting for a red light or something, the pulse width modulator will be turned up to the RPM that whatever I prefer, right? This might have to be a big motor because I want a noticeable amount of current going into here so I can actually keep the battery full. But then I can turn this off as needed. If the voltage gets up to 66 volts, I can turn this off. The pulse width modulator, just turn it off. And then if my battery starts to drop down to like 60 volts or 59 or 58 volts, I can turn this up, and it'll charge most efficiently when I'm not using this battery, right? When I'm not using my battery. This battery represents the battery inside the electric bike or scooter. So when I'm not putting a load on it, it's going to charge most efficiently, but when I'm putting a load on it, some energy can still be going in there. And ideally, I'm going to connect directly to the cells, because I don't want to be pulsing or whatever's happening with this motor, this line, these pulses. I don't want those hitting the BMS and weakening it. I don't know if that'll be an issue, or if that could do something to the battery management system. So, but I'll see how that goes too. Okay, everyone, there's the philosophy degree, which is to think about. It's the idea of thinking about what we're doing, and the philosophy and the poetry is loving giving path, right? So we'll go ahead and call this the loving giving path right here. So we'll say loving giving path, right? Because we're sharing the energy of this battery, these batteries, these two batteries. We're sharing it with another battery, and on the way to that battery, we're splitting the positive, and you can also split the negative. I don't know if you could split both of them at the same time, and I also don't know if you could put two motors in here instead of just one, if you could put two. I've tried that before and different things happen, but I know one works really good. If I put two motors in here, I don't know how what that does exactly. That would have to be experimented with. It has different results. But I do know that this can be a small motor or a very big motor, and the more current that takes is just the faster that this battery charges. But with lithium, we never want to go past the voltage, so we have to manually make sure we never ever exceed the maximum voltage and not even get close to that voltage. It's not even worth risking that, right? And also not letting the battery get to a dangerous temperature. If it starts heating up because we're giving it too much current, that would be another reason to turn this down or off. And I'm not recommending anyone do this. This is just like a thought experiment. But what a fun idea, right? What a fun idea. And it will be something I'm going to be experimenting with. I have experimented with these kind of circuits on the bench top. On the bench, like just putting motors and batteries together. And I've done all kinds of different experiments like this. But now I'll be moving up to the electric bike version where I can extend the range potentially of the electric bike in this simple way using what I have, without making this battery or buying this battery. I can just use these two, a pulse width modulator, have the negative, so the positive and negative from this battery are going to go to this. What's required is that this voltage be higher than this, or it won't work. So, and not just by a couple volts, it should be a significant amount, right? So it's 66, 76, 86, we're like 18 volts over here. That's a good amount. So I think we want to be probably at least 12 volts higher on one side, right? At least. But you can also see for yourself how that works out. It could be that the higher voltage this is possibly the even more efficient it is, right? But we never want to overload this battery. We never want to overheat this or overcharge it, right? Now, if it's lead acid, if these are all lead acid batteries, then lead acid is more can be charged to a higher voltage than 12 volts. I've been up to 16 volts, and I've heard people have gone up to 40 volts. And I'm not saying to do that. These are just research notes. Okay, everyone, have a great day. See you in the next video.